All right, here we go. We are going to continue with section 5.5. The lesson today in this video is going to be over the half angle formulas, and here you can see they are listed, and if you want to pause the video and make sure that you write these equations down. The tangent equation, there are two separate ones. You can go with either one. All right, let's go ahead and look at our first example. So we need to use this triangle here and find the half angles for each and evaluate them. I know that if I have legs of 7 and 24, Pythagorean theorem would indicate that the third leg, or the hypotenuse of this right triangle, is 25. When using, let me go back to these formulas. When using the sine and cosine formulas right here, we actually have to determine whether it's positive or negative, and that's going to be because of the quadrant. Whatever quadrant that we are in for our angle, then we are, that'll tell us whether we're using the positive or the negative of each of these. So those symbols come back with, we have to identify specifically which one. So I guess in this case right here, I was given 7 and 24 and 25, so they're all positive. So we're in quadrant 1. All right, so my formula for sine is positive then, square root of 1/2, and underneath here we do 1 minus cosine. So it's 1 minus the cosine. Well, the cosine is 24/25. So that would be positive square root of 1/2. If I subtract 1 minus 24/25, then what I would get is 1/25. So we're looking at the square root of 1 over 50, which is 1 over, and if you take the square root of 50, it is 5 square roots of 2. So not my final answer, because what I'm going to do now is I'm going to rationalize my denominator. So root of 2 over, multiply the bottom by the root 2, you get 5 times 2, which is 10. So there's the sine of the half angle. Let's do cosine of half angle. So I know cosine, again, it's positive. Square root of, it's 1/2. 1 plus cosine of x. Cosine is 24/25, which would equal the square root of 1/2 times 25/25 plus 24 is 49/25. This gives me the square root of 49/50, which equals 7 over 5 roots of 2. 7 divided by 5 roots of 2. I'm going to multiply top and bottom by the root of 2, and again, I would get 7 roots of 2 over 10 for my final answer. All right, tangent. So my tangent formula, I'm going to go ahead and I'm going to use the sine theta over 1 minus cosine, and that would be fine. So we've got my sine of theta is, or sine of x is 7/25 over 1 minus cosine, and cosine is 24/25. This equals 7/25 over 1/25, multiplied by the reciprocal, 7/25 times 25 over 1, and we simply get 7. So 7's the solution here. Something else that you're going to be able to do is you could take the results of sine and cosine and find the ratio of sine to cosine, and that would also give you results for your tangent. All right, so that's how your formulas work. Let's go ahead and attempt in our second problem. Use half angle formulas to find the exact values of the following: cosine 165, tangent 157 degrees 30 minutes, and sine 7/12 pi. Well, these are already half angles, So instead of doing 165, I want to double that and write it as cosine of 1/2 of, and if I double this angle, it's 330. So there's your half angle using 330. 330 is in quadrant 4. This was quadrant 4, and so I know the cosine in quadrant 4 is positive. However, we actually need to look at the half angle. So we're not looking at quadrant 4, we're actually looking, where's 165 at? Well, 165 is in quadrant 2. We need to look at the 165, not the 330. All right, so quadrant 2, then I know my cosine is negative. So negative square root of, and it's 1/2, 1 plus the cosine. And what is the cosine value of 330? What's the cosine of 330? The cosine of 330 is the root 3 over 2. All right, so that's what I need to simplify. And as I simplify this, I'm going to have negative square root of, I would have 1/2 plus the square root of 3 over 4. Combine these with a common denominator and multiply this by 2, so it's 2 plus the square root of 3 all over 4. Well, I can simplify that with the square root of 4, so I have negative square root of 2 plus the root 3, and that is all over the square root of 4, which is 2. And really there's not a whole lot else that I can do with that expression, so that's my final answer. I don't know if you're familiar with minutes, but minutes is out of 60, 30 out of 60 minutes, which was a half. So we're looking at 157.5 is what we're looking at. So if I double 157, and actually 157 here with my tangent, it doesn't matter which quadrant I'm in because tangent doesn't have the plus or minus version. But if I double 157.5, then I'm looking at 1/2 of 315. Okay, so we're looking for half of 315. This time in my tangent formula, I'm going to do 1 minus the cosine of 315 over sine of 315. I'm going to do this formula. All right, 1 minus cosine of 315. So 1 minus, the cosine of 315 is the root 2 over 2. And the sine of 315 is negative root 2 over 2. All right, so what I'm going to do right now is on top I'm going to go ahead and combine my like terms, combine my expressions, so it would be 2 minus the root 2 all over 2 divided by negative root 2 over 2. It's time to multiply by the reciprocal, so we've got dividing here is turning this into multiplying by the reciprocal, and let's see what we have left. So my 2 is going to cancel here, and what I have is I have 2 minus the root 2 divided by a negative root 2. Multiply top and bottom by the square root of 2, rationalizing this. I'm going to have 2 square roots of 2 minus 2 all over a negative 2, and finally what I can do is divide. So you've got negative root 2 plus 1. So there's the answer or the result to the tangent of that angle. All right, we're going to do one more here, sine of 7 pi over 12. Find another page for this. Sine of 7/12 pi. Well, if we want to do this by doing a half angle, then I'm going to do sine of 1/2 of 7/6 pi. So we're looking for 7/6 pi. my 7/12 pi, this is what the angle that we're trying to find, so I need to know what quadrant that we're in. Seven twelfths pi, that is going to be in quadrant 2, so I know that my result is going to be a positive square root when I go ahead and find this. So positive square root of, we're using the half angle, so I've got 1/2 times 1 minus the cosine, so 1 minus cosine of, and what I would want to do here is do the cosine of 7/6 pi. All right, let's simplify this. So we've got square root of 1/2, 1 minus, and the cosine of 7/6 pi is a negative root 3 over 2. So this would equal square root of 1/2. I'm going to go ahead and do a common denominator and try to multiply then, or change my signs. So I'd have 2 plus the root 3 all over 2, multiply by the half. This would equal the square root of 2 plus the root 3 all over 4. And then that can be simplified to the square root of 2 plus the root 3 all over 2. All right, there's your final answer there for the sine of 7 pi over 12, using the half angle of 7/6 pi. All right, in this next problem, I'm going to go ahead and set it up for you, but have you pause and try to attempt the problem so that you can see if you can get through it. We're using half angle formulas to find the exact values of the following. What we know is that cotangent of the angle is 7, and we've got pi, our angle is between pi and 3/2 pi. All right, well, what I do know is that originally here, this angle is in quadrant 3 somewhere, and if we're in quadrant 3 and the cotangent is 7, then what I know is I know that the x has to be -7 and the y has to be -1, and then the r would be the square root of 50, which is 5 roots of 2. Okay? Now when we're doing half angle here, because of the sign, we need to decide which quadrant are we going to be in? Is it positive or negative? To do half angle, what we would want to do is we cut our interval in half, which would make this between pi over 2 and 3/4 pi. So we're cutting our interval in half. Which quadrant does that lie in? Well, this is quadrant 2. So we're looking for quadrant 2 for the sine and cosine. That indicates that the sine is going to be the positive square root of, and the cosine is going to be the negative square root of. And now tangent doesn't matter. So what I want you to do is pause the video and see if you can substitute using those formulas, using here the right triangle, the x, the y, and the r. And then I will list the answers for you to check. All right, here are your answers to go ahead and check. Now in the middle of all this, there was a lot of simplifying and also rationalizing your denominator, and so that's how the 10 comes about. Okay, but go ahead and check to see how you did there. We're going to move on here now to the next and last problem that we're going to do here in this section, and that is solving. Solve this equation using our half angle formulas on the interval of 0 to 2 pi. Well, I guess the first thing that we're going to do is we've got this equation and we don't have everything in the same term. You've got sine squared, so I'm actually going to write that sine squared as 1 minus cosine squared of the angle. It doesn't matter what the angle is, these properties work. Equals cosine of x. And then I'm going to distribute 2 minus 2 cosine squared of x over 2. I'm going to put this in a quadratic form here. So I've got 0 equals 2 cosine squared of x over 2. And I've got the plus cosine of x and minus 2. All right, the next thing I'm going to do is substitute my half angle formula. So 2, I don't worry about it being positive or negative at this point in time because I'm going to end up squaring it. So by squaring positive or negative, it becomes positive. So I'm not going to worry about that, but I'll show you the signs anyways. I'm going to substitute my formula, and that whole cosine of x over 2 is being squared. So my formula is plus and minus the square root of 1/2 1 plus cosine of x, plus cosine x here, minus 2. Well, when I square this square root and the plus minus, it becomes 2 times 1/2 1 plus cosine of x plus cosine of x minus 2. And this is all still equal to 0. So 2 times 1/2, I can cancel out my 2's, and I've got 1 plus cosine minus 2. This equals 0 equals 2 cosine of x, and then 1 minus 2 is minus 1. Okay, I'm just combining my like terms there. These cosines add together to be 2, and then 1 minus 2. So we're solving here, you get 1/2 equals cosine of x. So within the interval of 0 to 2 pi, when is cosine x equal a positive 1/2? And that occurs at pi over 3, the 60-degree reference angle, and then 5/3 pi in quadrant 4, because that's when cosine's positive. So there are my two solutions. Here's your assignment for this last part of section 5.5.